Example 8, we're going to use property 8 to estimate the integral going from 0 to 1 of e to negative x squared dx. Now remember, this is property number 8. Okay, before we do that, let's take a look at what this graph looks like. So we're going to go ahead and graph e to the power of negative x squared. Okay, and then we know it's going to be in between 0 and 1. So we're going to have the lower at 0, and then we know it's 1. So there is our function. Okay, so what can we say about this function right now? Well, if we look at this, we know it's a decreasing function because it's decreasing on the interval from 0 to 1. And it has an absolute maximum. Okay, so here's your absolute maximum. And there is, let's see here, your absolute minimum. Okay, which would be 1 e to the negative 1. Okay, so let's go ahead and write that down. So what do we know? We know that f of x, which is equal to e to the negative x squared, is a decreasing function on the interval from 0 to 1. Okay, and we also know that the absolute maximum, which we call capital M, is the point of f of 0, which is equal to 1, and its absolute minimum, which is lowercase m, which is equal to f of 1, which is equal to e to the negative 1. Okay, so let's take a look at this graph now. So here we can see that we have the maximum of m, which is the absolute maximum. This is the absolute minimum. Okay, so there is the absolute minimum, there is the max, and there is the minimum value. Okay, so by this property, and then using property number 8, okay, we can take a look at this integral. We can say that, okay, well, we know that the value of m is going to be less than or equal to f of x, which is going to be less than or equal to m. Okay, and so what does that tell us? Well, that tells us that this integral of m here, and we know that on this closed interval from a to b, okay, so what is that lowercase m? Well, that lowercase m is e to the negative 1, or 1 over e, right? So that means that we have e to the negative 1. And so using this property here, we know that this is e to the negative 1, which is less than or equal to f of x, which is less than or equal to the maximum, which is 1. Okay? And again, that's on the interval from 0 to 1. Okay, now, again, using property 8, we're going to take that m, lowercase m, and multiply it by b minus a. And then it's going to go from the integral from a to b of f of x dx, which is less than or equal to the absolute maximum times b minus a. So we know that lowercase m is e to the negative 1, and then b minus a is going to be 1 minus 0, and that is the integral from 0 to 1 of e to the negative x squared dx, which is less than or equal to the absolute maximum of 1 times 1 minus 0. Okay, so now let's go ahead and take a look at this a little further. We're going to get e to negative 1 times 1, which is going to give us e to the negative 1, and that's going to be in between this integral, negative x squared dx, going from 0 to 1, and this is 1 times 1, which is 1. Okay, now what does e to the negative 1 equal, which is the same thing as 1 over e? Well, it's approximately, to 4 decimal places, 0.3679. So that tells us that this integral, or the area of that integral, is going to be in between this value. It's going to be in between 0.3679 and 1. Okay, and so we saw that the result of this example is illustrated in the figure above, and the integral is greater than the area of the lower rectangle and less than the area of the entire square.